Hi, I'm Jez and welcome to this class on calculating image file size. Hopefully you've taken in the introductory video into binary conversion. The work that you've done in that class will help pave the way and put you in a strong position for this class. So let's get started. Let me share my whiteboard. I'll be drawing on the whiteboard again, so do excuse my poor artwork. Okay, so we are here to learn about how to calculate image file sizes. So I have an image here, okay, could be, I don't know, a landscape, could be anything, could be absolutely anything. Now, if I was to get a magnifying glass and sort of zoom in on an image, what would I see? I would most likely see the image is made up of tiny squares of color. And if you sort of squint and look very closely at your monitor, depending on the resolution of your monitor, you could probably see those tiny little squares. Those squares are called pixels. Pixels, so it's these tiny squares of color that make up images and, well, what you're seeing on screen at the minute. Now, each of those tiny squares can be any color under the sun. And depending on the amount of different colors a pixel can be, it is determined by how much information can be stored for each pixel. Okay, and this capacity of storing information in a single pixel, it's stored in bits. So this is where binary comes in again. So one column on my conversion table from the previous class, that one column, that one box is a bit of information. So if one pixel in my image, every pixel in my image can only store one bit of information, then that binary bit could either be a 1 or a 0, can't it? It can't be anything else. There's only two different combinations it could be. So what a 1 could be black. I did apologize for my handwriting, didn't I? And a 0 could be white. Okay, so an image with a color depth of 1 bit can only be a black or a white. It'll be a black or white image. But what happens if we start to increase the color depth for each pixel? So we have a pixel here. Let's say it's got a color depth of 2 bits. So how many different combinations do you think that pixel of with 2-bit color depth could be? Well, it could either be a 0, 0. So think back to the previous class on Introduction to Binary, and we look at that table. We're now concentrating on just 2 columns of that table. So we could have a combination of 0, 0, 0, 1, 1, 0, or 1, 1. So it could be 4 different combinations. And usually the 0, 0 is a white, and maybe 1, 1 is a black, and the bits in between are different shades. So what we're getting at here, we're probably spotting a pattern now, that an increase in color depth, so the amount of bits per pixel, as that increases, the number or the amount of different colors and combination of shades that pixel can be also increases. So it might be worth trying to work out how many different combinations a color depth of 4 and a color depth of 8 could be. And then you'll begin to see a pattern, the rate in which it increases. So the bigger the color depth, the bigger the bits per pixel, the greater the color depth, and the more combinations and different colors you can use within your image. So with that in mind, then, how do we calculate the file size of an image? Well, again, it's using a bit of simple maths, and If you were presented with a question in an exam that involves calculating file size, chances are you will not get a very complicated one to do, because we're not allowed calculators in the exam. It's all done in our heads. So they understand this, so they won't present you with a hugely complicated equation to do. So how do we calculate this image size? So let's say this image on screen, this rectangular image, is 200 pixels by 500 pixels. Okay, we need to know how many pixels wide and how many pixels high it is. We also need to know the color depth. So maybe our color depth is 8. So every pixel in our image has a color depth of 8 bits. So once we know those 3 key pieces of information, we're in a strong position then to calculate the file size of our image. And we do it simply by taking the dimensions of the image and timesing it. Okay, so we're basically calculating the area in pixels, the overall area of our image, and then we times it by 8 to get the color depth, to get the image size. Okay, now this image, the result you will get an answer of the file, of how big a file size will be with this image. But the important thing to remember, the really important thing at this stage, so you've got your answer, your answer will be in bits. Okay, it'll be in bits. At that point, I would always recommend to my pupils that they reread the question, because sometimes it's quite common for the question to ask you to present your answer in megabytes, for example. So you've got it in bits. It is correct. It is correct, but you then need to do a further conversion to obtain your answer in megabytes instead of bits. Let me explain. So if I was to clear this, okay, so we have bits. We have a bit of information, and a bit is, well, it's one column on our binary table, isn't it, from our previous class. Four columns on our table, okay, is what we call a nibble. Okay, so a nibble is 4 bits. A byte is 8 bits. So a byte is 8 columns wide from that table. So a byte is 8 bits. And you've probably heard of these kilobytes. Okay, kilobytes. Again, if you open your file explorer on your desktop from your computer, you will see your files in there. Most of the time are measured in kilobytes. They're abbreviated to KB, maybe. Okay, KB, and there are 1,000 kilobytes in a byte. Sorry, 1,000 bytes in a kilobyte. Okay, for ease of calculating, it is 1,000. Technically, it's slightly more, but to make it easier to calculate file sizes mentally, it is 1,000 bytes in a kilobyte. You probably heard as well, we have megabytes. Okay, megabytes represented by MB sometimes. And again, there are 1,000 kilobytes in a megabyte. And the next one along is gigabytes, and again, there are 1,000 megabytes in a gigabyte. So using these units of measure, you are able to take your final answer of your image size, which you would have worked out to be in bits, and you can sort of use these values to convert it into whatever unit of measure that has been asked in the question. Usually it's kilobytes. Most of the time, though, it's in megabytes. So they'll say, please calculate this image size that is 500 by 1,000 pixels that has a color depth of 16 bits, please present your answer in megabytes. Okay, so you would use that process that we've just stepped through to work out the number of bytes, to work out the number of bits, convert those bits to bytes, bytes to kilobytes, and finally kilobytes to megabytes. I am getting a bit tongue-tied, but you get the idea. Really important, same advice as I mentioned previously in our binary, always show your working out, especially with these types of questions, because even though you don't get your final answer correct, or maybe you forgot to convert the bits into megabytes, you can still get marks for showing your working out and demonstrating that you understand or fully understand the process that you need to follow in order to calculate file size. So always show your working out. Give it a go. All we need to do is just follow the same process I did. Just draw a rectangle and give it some random dimensions, and probably go with like an 8-bit color depth or a 16-bit, and see what answers you get. And then you can practice converting those results in bits all the way through to megabytes. And if it's a massive image, maybe gigabytes perhaps. I don't know. Give it a go. Practice is the key in this case. Okay, I hope you found this useful. Apologies once again for my bad handwriting, but I hopefully it helps you understand the process of calculating image sizes. Thank you.